hoop values were coming infinity, we were spreading this lantern to certain distance. That is, here we have spreading it to 4 meters. So the area over which this lantern is spread will be pi d square by 4. So we are assuming that this is the diameter, that is 4 meters. So entire this area, it is being spread. So we will find out the area as pi d square by 4, and the intensity of the load will be 20 divided in 20 is the load of this lantern, and per area 12.56. So you will get an additional load of 1.59. That is when you are considering, so if this is the dome, so if you are considering a small portion, that is if this is the axis from 0 to, if you are considering this angle, that is if 0 to 7.7 degrees, there will be an additional load. That is our initial was 5.5 plus 1.59. So for if theta value is greater than 7.93, the WUDL will be 5.5 mm. So at the crown, theta will be equal to 0. That is, at this point, this is a crown, theta will be equal to 0, and the thrust and the hoop force will be WR by 2. So you have to substitute the theta value and you will get just 51.4. So you will write it in two terms, that is small w and capital W. Small w is due to this UDL and capital W is due to the point load. So we know the both the equations. We will substitute into that and we will find out what are the values. So for angle theta is equal to 0, we know that due to this UDL, so theta is equal to 0, UDL will be 7.09 into 14.5 divided by 2. So since we are giving the cos theta value, and due to this point load, it will be infinite. So we will add these two, that is here we will have 51.4 and here it will be infinity, so we will keep it as blank. So we will find the total, we will write it as 51.4, that is the total meridional thrust. And for 7.4 angle less than 7.93 degrees, or we will consider it as 7.93 degrees, we will similarly find out what is the meridional thrust due to this UDL and due to point load. You can see that the equations. So here you can see the equation. The meridional thrust due to UDL is small w r by 1 plus cos theta. W is nothing but the UDL. Load corresponding to this UDL, and T will be equal to, due to point load, W by 2 pi r sin square theta. So W will be the load due to point load. So if you are substituting these two, we will get these two thrusts and we will add these two to get the total. So for 20 degrees, 30 degrees and finally 43.6 degrees. That was the angle that made by this end of this dome, line joining the end of this dome to the center with this vertical axis. So we will find out the total forces. Similarly, we know the hoop force equation corresponding to UDL at point load. So using that, we will create another table and wherein which we will write out those values corresponding to that and we will find out the sum.